In this lesson, we are going to look at scale factors and areas of two-dimensional shapes. If the scale factor between two similar figures is a to b, then the ratio of their areas is a squared to b squared. So you need to square your scale factor to find the ratio of the areas. That can be just the ratio of area, surface area, lateral area. If the word area is involved, you square the scale factor. So if the scale factor of two hexagons is 4 to 5, find the ratio of their areas. Now we're not finding what their areas are. What we are doing is we are determining the ratio between the areas of the two hexagons. We know that the scale factor is 4 to 5. We know that the ratio of areas is scale factor squared. So it's 16 to 25. And from here you could determine how many times bigger one of them might be, etc. So ultimately this is the ratio of their areas. If the ratio of the areas of two triangles is 16 to 49, find their scale factor. So here we're working backwards. We know that we square the scale factor to find the ratio of the areas, but if you're given the ratio of the areas, you square root to find the scale factor. So it'll be 4 to 7, and that would be the scale factor for these two triangles. Determine the scale factor that relates EFGH to ABCD. What we are given is the area of each. So what we want to do, we want to relate EFGH to ABCD. So EFGH needs to go first. So here's the area of this polygon, 11.25. And the area of ABCD is 5. So we're comparing EFGH to ABCD. Now what we can do is we can write this then in fraction form, because that's another way of writing scale factor. Now remember, these are the areas. This is now a ratio of the areas. We want to work backwards to scale factor, so we need to square root this. Now you can either square root each part individually and then divide the numbers, or we could divide and then square root. It really doesn't matter. So we have the square root of 2.25, which is 1.5. So the scale factor is 1.5. You can leave it in decimal form. We know that that's also 3 over 2, which can be written as 3 to 2. So there's many different ways you could write that final answer. Ultimately, we were given the areas. We wanted the scale factor, so we had to square root. Jasmine is making a kite from a 2 to 25 scale diagram. The area of the scale diagram is 20 centimeters squared. How much fabric will she need for her kite? So what we know that the scale factor is 2 to 25. We are talking about area. So we need to square these so we can set up a proportion and find our answer. So we have 4 to 625. There is the ratio of the areas. So what we know, (4 to 625), the area of the scale diagram is actually 20. So now what we can do is we can find the actual area of the kite. Cross multiply. We get 12,500. Divide by 4. The area of the kite is 3,125 centimeters squared. So how much fabric would she need for her kite? Well, we could change this to meters for her. 31.25 meters squared of fabric is what she would have to buy. So the keys are, if you know scale factor and you want to find the ratio of areas, you square your scale factor. If you know the ratio of the areas, you square root to find your scale factor.